Hello friends, today we are going to see the various characteristics of sensor, and depending upon that characteristics we have to select the sensor. The characteristics of sensors is depending upon the various purpose how it will be used by the sensors. Now we'll start with here the characteristics of sensors with some characterized depend on the value of some of parameters. So what are the some parameters? It can be depending on input characteristics, and that parameters can be depending upon transfer characteristics or can be output characteristics. So as you see, the various parameters depending upon the purpose of a sensors. In the same way, the characteristics of the various sensors is also depending upon their characteristics. So the input characteristics, output characteristics and transfer characteristics. However, the performance of a sensor is also judged by another characteristics, or you can say various categories. So depending upon the which instrument we are using the sensor, another performance characteristics is to be categorized. So one with the static characteristics, the second is a dynamic characteristics. Obviously, the word coming static means what? The slowly changes the value or the signal or the quantity changes with respective time is slowly. That is called static characteristics. And the value, signal or the quantity is changes abruptly, speedily, or you can say instantaneous. That is called dynamic characteristics, and it is change with respect to time. So we'll see whole the definition of a static characteristics, that is the instrument characteristics which determine the quantity which are slowly changes with respect to time or predominantly constant with respect to time. So there are sensors which the sensing value is constant with respect to time, or it change the value with respect to time but in slowly manner. There are other sensors which sense the value instantaneously with respect to time. So the instrument characteristics that determine the quantities which instantaneous change with respect to time or abrupt change with respect to time. So that is dynamic characteristics. Now input characteristics of a sensor will start. So we will start with various characteristics of a sensor that is in input side. See, the thing is that the sensor part is there. The value what are coming on the input side are the physical quantities, and the output side of the sensor, all the values is can be voltage or can be current. So for the input side, it will be first parameters are the physical parameter that we have to see with their characteristics. So it start with the range. It is the minimum and maximum value of a physical variable that the sensor can sense or measure. For example, a resistance temperature detector, that is the RTD sensor, for the measurement of a temperature, and that is the range. It is the widest range from minus 200 degrees Celsius to 800 degrees Celsius. See, the purpose of a RTD is defined by its range, that is minus 200 to 800 degrees Celsius, and that's why the value of physical variable is important. Now the second part is span. Now what is the change between span and range? It is the difference between maximum and minimum value. Okay, so the range is the minimum and maximum value, but the span is the difference between maximum and minimum value of an input. So in the example is the span of RTD is 800 minus 200, which will get 1000 degrees Celsius. Okay, so as you see here, if the minimum value is less than 0, the overall span of particular sensor is higher. But if the minimum value is greater than 0, the span value of a sensor can be less. The same example is given is here RTD. If the minimum value of RTD is not minus 2 degree, but if it will be plus 200 degree, then our span value is changed. That means 800 minus 200, it become 500 degrees Celsius. But here the minimum value of a sensor is minus 200 degrees Celsius, and that makes us change, and that sounds good. Now the second part is the accuracy. So what is that accuracy? The error in measurement is specified in terms of accuracy. It is defined as the difference between measured value and the true value. See, there are two terms is again coming, that is the measured value and true value. So the measured value can be from input to output. That means from minimum value to the maximum value. But it can be happen that is a true value also. So what is a true value? True value is the predefined value that already enter in the sensor device, or it can be considered as a measuring devices. It's already defined. So the difference, again the difference between the measured value and the true value is the accuracy. For example, then defines in from the percentage or the full scale in also in percentage. So we can consider a particular sensor which having a particular value with 80% accuracy, but if it is calculated in ideally, we can consider it in 60%. So the difference between 80% and 60% is 20%. So the true value and actual value, the difference is 20%, and that is called accuracy of a sensor. That is the characteristics of the sensor. Now, absolute error. Absolute error is the measured value minus true value. As I am saying earlier, the true value is the predefined value of a sensor, and the measured value is the actual output coming from the sensor. Now XA is the measured value, that is already output side, and XT is calculated by taking the mean of infinite number of measurement. So we consider the major difference between the measured value and the true value is EA, that is absolute error. Now the next part is the relative error. If we consider the error is happened in the sensor that has to be divided into two parts, that is the absolute error and the relative error. So the absolute error in ideal way, it is very low. So when absolute error is very low, depending upon relative error is maximum. So in ideally, relative error should be high and absolute error should be low. Now the precision. What is the precision? It is defined as the closeness among a set value. Set value means what? A predefined value. It is different from the accuracy. let's consider xt is a true value, xt is a true value, and the variable with the experiment measures x1, x2 up to xi. As the value of x we consider, we will say our measurement x1 up to xi, and the precise when they are near to the necessary close and true value is xt. However, it will say that the x1 up to xi is accurate. It means that they are close to the x2 and hence they are also close to each other. Hence, accuracy measurements are always precise. Means what? Suppose xt having particular value and we are calculating or we are measuring the value from x1 up to xi. If up to xi, whatever the value is coming, if it is closer to the xt, that will be a precise value. But if it is not possible with the various conditions or various predefined parameters, it may happen that the value of xt or xi can be changed. We can show in this example also. See here, if this dotted line, I will consider with this example where xt is our predefined value or the set value and x1 up to xi calculate here. So xt value, when xt value and xi value is closer to it, we become high accuracy and high precision value. But it may not possible with the various condition also. So xt and xi having some difference, that can be a low accuracy or high precision. That means what? The accuracy can be low, but the precision part is high. It is the main part is there. But see here, the part of x1 up to xi making not clear here. It's abruptly changed with this area, and here is whatever the value of x1 to xi is close to each other, that is called high precision. But here is whatever the value coming from x1, x2 up to xi, x1, x2 up to xi is separated with the area, means not close to the area, hence it is low precision. Obviously, a low accuracy means it is not setted with this particular thing. Hence, it is, we can conclude that the ideal condition, high accuracy and high precision is required. Now, we'll move to next part, that the fifth characteristic of the sensor is the sensitivity. Now, what is that? It is the ratio of change in the output to the change in the input. Is same as the gain of particular devices. Here we consider as a sensitivity. It is the ratio of change in the output to the change in the input. So consider here y is the value of the output quantity and x consider as the response of input side. Then the sensitivity S can be expressed by deviation change with the output to the deviation change in a x. That's why it is the ratio of output change with respect to input change. Now, we will move to the next part, that is linearity. Linearity is the maximum deviation between measured value and the sense ideal value. So, if a sensor sense particular value, when it is tested in a lab, it shows the value in ideal way. Here is ideal curve. So when we learn about linearity, it is with input with respect to output, the measured value coming in a curve. The measured value coming in a curve. And whatever the difference between that measured curve and the ideal curve, that is called maximum error. And here shows the linearity characteristics of the sensor. Now, resolution is the minimum change in an input that can be sensed by the sensor. So it may happen with any conditions that the change in the input, and that is sensed by the sensor, that is called the resolution. Now, reproducibility is again an ability of sense to produce same output when the same input is applied. Means what? If the same input is coming, we are expecting the same output, and that is called reproducibility. Again, repeatability. Here, many students make mistakes the difference between the repeatability and reproducibility. So what is that? It is defined as the ability of a sensor to produce the same output every time when the same input is applied. But all physical and measured condition kept in operating instrument and the ambient conditions. Means what? If the ambient condition, that is the temperature changes, it may happen if the instrument is changed or if the operator is also changed, but that should not be affected. Hence, repeatability makes an constant. Now, the response time. The response time is generally expressed as the time at which the output reaches a certain percentage. For instance, it can be considered as a 95% and of its final value in response to a step change in an input. Means what? Means what? If I consider the 95% accuracy is coming up to certain percentage and the final value in response a step change in the input. It can be happen that the input is coming with the first changes, but the output we get at up to 95%. We have seen total 10 characteristics of the selection of the sensor, or you can say input characteristics of a sensor. So obviously, whatever the value coming on the with respect to the input value of a sensor, we have to consider in input characteristics of the sensor. And here we end this topic. Now, the types of sensor is depending upon that characteristics. We are already seen the characteristics of a sensor. Now, it is time to see the types of a sensor. Now, the types of a sensor here is the various types. So various parameters depending upon the characteristics, the type of sensor is depend. First is an active and passive types. So does sensor draw energy from the signals? This is the question arises, and the answer is whether we have to use the active sensor or whether we have to use the passive sensor. Again, digital sensor or analog sensor. So it is depending upon the signal is what the output is got, either is discrete signal or whether it is continuous signal. Obviously, if the signal is continuous, then the sensor is analog. If the signal is a discrete, then the sensor is a digital. Same way, if the condition is a null, then the null or the deflection method is used as a sensor type. Now another is input and output configuration. Same way, if we consider is an input characteristics or we consider as an output characteristics, Then input and output configuration is also important. Now we will see the active sensor with respect to the passive sensor. Before that, we have to know what is active sensor and what is passive sensor. Let's start with the active sensor. Require an external source of power, that is excitation voltage, that provides the majority of the output power of the signal is an active sensor. That means it's require an external source of power, that's why it is active sensor. Now the passive sensor, the output power is almost entirely provided by the measured signal without excitation voltage. That is the important thing, hence it is passive sensor. So why it is called passive sensor? Because it's without an excitation voltage. Now the time is for digital versus analog sensor. So what is a digital sensor? The signal produced or reflected by the sensor is in binary. Means what? Whatever the output coming from the sensor in the form of binary, that is in digital sensor. With analog sensor, the signal produced by the sensor is continuously or proportional with respect to time. It is called analog sensor. Now it's time for again null and deflection methods. So null method is a different thing and deflection method is different thing. So start with the deflection methods. The signal produce some physical phenomenon. It can be deflection when the effect closely related to the measured quantity and transduced to be observable. Means what? The physical quantity effect closely and that measurable quantity, and that has to be in observer. So this is deflection method. The second part is a null. What is that? The signal produced by the sensor is counteracted to the minimize the deflection, that opposing the effect of necessary to the maintain a zero deflection should be proportional to the signal of the measure. Means what? Whatever the output we are coming and whatever the deflection has to be happened is should be nullify, or you can be considered as a removing side, and we get a zero deflection, that is called a null method. Now input and output configuration. So for this configuration various method is there. First is method of inherent insensitivity. Use whether it is possible. Whatever the possibility method is there is almost used in this first method. Second is high gain feedback. Third is calculate output correction. Fourth is method of signal filtering, and fifth is method of opposing input. See here, I will see you in details, that is the various input. So desired input is the predefined parameters. Modifying input is coming from the feedback side, and also it is depending upon the errors. And the interfering input is the actual input coming from the physical phenomena, and here we get our desired output. Now next part is the interfering input, the quantity to which the instrument is unidirectionally sensitivity, that is interfering input. Now modifying input. What is modifying input and what is interfering input? Interfering input is in Unintentionally sensitivity means what? Whatever the changes is to be happen, it should be an unit wise, and modifying input is depending upon the input and output relations. Hence it cause the changes of the modifying input. Our third part is an example where the temperature, atmospheric pressure and the magnetic field is depend. See here, the method of high gain feedback is calculated with the open loop system. The open loop system which having only input and output, but the feedback system is absent here, which is coming from the output and again connected to the input. So that's why this system is called open loop system. Consider x0 is the output where k1 and k2 is the input. So any modification in k1 and k2 is responsible for the changing in desired output. We can elaborate this phenomenon with the diagram where k1 and k2 is a system with coming with the independent input. Consider k1 having desired input and k2 with the output x0. So we will get that high gain feedback. Now consider Ka is a modifying input A, K1 is a modifying input 1 and K2 is modifying input 2, and overall modifying input is F. So F should be a feedback part. Input 1 and 2, that is the K1 and K2 is an modifying part. Now method of calculated output correction. Measure or the estimated the magnitude of interfering of modifying input and the subtract from the signal to calculate correct output. The correct output is calculated with the modifying input and the subtract from the signal. So whatever the signal is coming, whatever the interfering or the modifying signal input is coming, that has to be subtract and that is calculated the output correction. See in the diagram, interfering input, modifying input and the desired input are again applied these particular systems, and again the modifying input connected to the output which is given for the calculation of output correction. Now next part is the method of signal filtering. This method is used for the whatever the signal is coming, whatever the actual input is coming with another unwanted signal. To remove this unwanted signal, the signal filtering is required. So the interfering input with the modifying input and the desired input, the desired input are coming directly to the system, but the modified input and the interfering input required filters, and with addition of interfering, modifying and the desired, we will get our desired output, and that is the signal filtering method. Now we'll move to another method, that is output filtering method. So in the same way as we seen in the input side, for the interfering and the modifying input we require a filter. Obviously for the desired input is not required is a filter, but in the output side also the interfering input and the modifying input we required a filter, and we will get the output filtering method. Now what are that filter is required as well as for the interfering and modifying input, that is low pass filter, high pass filter, band pass filter and band rejection filter. So it is a simple thing where we have to consider the filter and where their types. Simple, if a filter is there with the no pass thing. Means what? The filter with no signal is passing basically. But if the low pass filter is there, it can be passed only and only a low signal. If the high pass filter is that it removing all the low pass signal and pass only a high frequency signal, and that can be programmed, or you can say a predefined in the sensor manner. Now the band pass filter is that it is the range is defined predominantly from the high to low or low to high, and that is range fixed is in band pass filter. In the same way, the band rejection filter is what? The minimum to maximum or to maximum to minimum, one particular range is decided and that has to be removed, and other signal or other frequency has to be accepted, and that is called band rejection filter. Now the last part we are coming with the method of opposing input. What is that? The interaction introduce interfering or the modifying input to cancel the undesired effect of other interfering input. See here, interfering input 2 and modifying input 2 is also there. So same way, interfering input 1 is here, interfering input 2 is also there, and the modifying input 1 is also there, and modifying input 2 is also there. Means what? At a time, two input is coming with various way, and we have to select, we have our option that which input we have to select, that is opposing of input and opposing of one input and accepting of one input. And here is the method of opposing input. Here at the end we are selecting various methods, and depending upon the purpose, depending upon the application, depending upon the condition, which method we have to consider. So the input, output and the desired method of a sensor. Thank you.